Good morning to people who are on the West Coast. Good afternoon if you're on the East Coast or somewhere in between. Welcome to our webinar. I'm Susan Metz, Director of Marketing for LTech. And in this webinar, we're going to be talking about realizing the cost savings and improved recovery and provisioning agility by moving your disaster recovery environment to Amazon Web Services. And this webinar is being recorded, so if you miss a piece of it, you can always revisit it again. We'll have it posted on our site this afternoon. Before I pass it over to our presenters, I just want to talk a little bit about the GoToWebinar control panel. You are muted. You're in listen-only mode right now. You do have two audio options. You can use the speakers in your computer by selecting this button, or if you select Use Telephone, you'll be provided with a telephone number and access ID, and you can listen through your telephone. We are going to have time at the end of the webinar to address your questions, so you can post them in the questions panel. You can ask questions throughout the webinar, but we do have time at the end for taking your questions. If you want to zoom in on the screen, you can click this button here. And if you just want to hide this whole panel, you can click on the double-headed arrow right here. So now I'm going to pass it over to Russ Young, our Executive Vice President, to get this started. Take it away, Russ.
Hey, thanks, Susan. And thanks everyone again for joining. My main role today is to be the game show host here and get out of your way so you can listen to Eric Klautzko, who's the smart guy at LTech. I think that's why you're all here. But just quickly, I'm the Executive Vice President and help run the cloud practice at LTech. LTech's been around about a dozen years. Just under 4 years, we've been an Amazon Web Services partner, mainly as a solutions provider. And have for the past, I guess it's been 4 or 5 months now, as a reseller for Amazon as well. LTech does 3 main services to AWS and to our customers. The first one is managed services. So a lot of folks we find moving to Amazon and to the cloud in general would also like to offload their managed services for infrastructure and for applications, and even on the software layer, we can provide custom services and support there. As I mentioned earlier, we're also a reseller. A lot of folks like a negative way to say it is one throat to choke, but also, one phone call to, take care of all the different things you would need to in Amazon. One thing we've been realizing the last, probably 6 months or so is there's even a lot of companies that are already doing a lot of stuff on Amazon, and maybe have a lot of folks even doing individual purchases on Visa cards. So we've been doing a lot of engineering to help folks, make plans around that, and make sure you don't, build the house and then realize you want a basement later, as well as saving a lot of money combining those accounts and doing reserves and such. The third piece is professional services, and that's one of the things we want to talk about here today. We do forklifting of infrastructure and applications and software into the cloud. We do build of greenfield applications, and we've been doing a lot of DRE, disaster recovery, as well as some cool things in test and dev to allow people to put their foot into the cloud pool. And see if I'm meeting my time frame. Now let's see if I can get out of the way. Eric, if you're on, Eric is our Vice President of Technology. And let me go ahead and turn it over to Eric so we can get into the meat of the presentation.
Good afternoon, everyone. Thank you for taking time out of your schedule to join the webinar today. We are going to do our best here to shuttle through quite a bit of content and find a good mix between taking a deep enough dive so that you understand some of the benefits, both technically and financially, of AWS from a disaster recovery perspective. In the webinar chat, if we're not striking that mix well, and you'd like to have a little bit more deeper technical dive, please chat that to the webinar panel, and vice versa if you'd like us to come up a level or two, and we can customize this on the fly. Certainly, if we are not answering any direct questions that you have because we run out of time, we're happy to meet with you offline and get any of those questions answered. At this point, you should be able to see my screen. No PowerPoint presentations today. We're gonna do this via virtual whiteboard. So I hope that presentation style suits you, and I think you'll find it to be interactive and informative. So welcome to the webinar. We're going to be talking about disaster recovery in the cloud, and the first thing that we're going to define are two terms: recovery time objective and recovery point objectives. And the reason why we're going to start here is because every organization has a recipe for these ingredients, and what is the tolerance for time and data loss when it comes to a recovery from a disaster of any kind. And a disaster doesn't have to be on wide scale, such as the East Coast experiencing Hurricane Sandy this past year, but instead it could be as simple as a power outage, or even human error, a technician deleting a database that they did not intend to, or something of that nature. So starting off here and understanding what your organization's recovery time objective and recovery point objective is will help us prescribe to your organization what is the most appropriate disaster recovery solution in AWS for your organization given your time and risk tolerances. Okay, so recovery time objective basically states how much time is appropriate for your organization, both from a business line perspective and a technology perspective. What is the expectation for after a disaster event for your organization production systems to be back online? So if the event happens at noon, if you have a 2-hour recovery time objective, then you're stating you want to be back online in 2 hours, and that's not necessarily online in production, obviously, but in a DR scenario that would be spun up and available to either your employees or users or whoever the consumers of your systems are. The recovery point objective is how much data loss is acceptable for your organization given a disaster event. So specifically, a lot of organizations back up to digital tape, and they do maybe weekly backups and incremental backups every night, perhaps, is a common scenario. And in a scenario where you have incremental nightly backups, if it's 11 a.m. and you have a disaster event and your organization's been online and working, creating transactions or work product for the first 2 hours of the day, those 2 hours would be lost in a nightly incremental backup solution to tape. And that is what recovery point objective is when we talk about how much data are you willing to do without when you recover to a disaster recovery environment. Okay, every organization has their own requirements, and AWS can support a similar model to tape backup, where you have nightly incrementals or nightly fulls, all the way to fully redundant transactional replication, where there's zero data loss. So before we dive into some of the solution models that are possible with AWS for disaster recovery, let's talk about for a moment traditional DR environments, which I'm suspecting will be somewhat familiar to this audience. When you look at spinning up a disaster recovery environment, one of the things that you always want to take into consideration is that, much like if something were to ever happen to the President of the United States, the Vice President is then matriculated into that role and has all those powers and responsibilities. Well, the same holds true for disaster recovery environments. So your DR environment needs to be able to be as secure as your production environment, needs to be able to scale to handle the volume of users and transactions that your production environment does as well. And all of the things that go along with production, from the power and cooling of the data center to the ability to replace disks in a drive array, all of the networking accoutrement of firewalls, routers, switches, and so forth need to be present, and it needs to be able to take over the full roles and responsibilities of a production environment. This is an expensive proposition when it comes to a rack metal environment and going to an auxiliary or a secondary data center and mirroring a production environment. It's a large capital investment, and it's a large maintenance and upkeep investment. So what is AWS and in relationship to disaster recovery? Well, it is not only a secondary, but it's a multiple uh, by a factor of 8 different regions data center possibilities for your organization. And on the screen now, you see the 8 regions for AWS that are currently available. And this would allow you not only to, let's say if you're on the East Coast, put a disaster recovery as a best practice, as a disaster recovery environment on the West Coast, but it would also allow you to put a DR environment in other physical locations around the globe that would reduce the latency if you're a global organization. Realize that the audience on this webinar might not have a global presence, but if you do, wanted to bring that forward. Implicitly in this multi-region, multi-availability zone architecture. An availability zone, by the way, there are multiple availability zones in every region, and it's a siloed compartmentalization of computing within each region that gives you fault tolerance. So the multi-region, multi-availability zone architecture within the AWS infrastructure allows your organization not only to have a global presence, but it gives you that siloed redundancy either on the continental U.S. or across the globe. We're about to dive in to some of the to some real use cases, which is I think why many of you are attending. But before we do, one last set of definitions, and we'll be off to the races. So at the top of my screen, you see these 8 colored icons here. Just want to quickly breeze through some of these 8 colored icons because we're going to be referring to some of these in the next part of the webinar, and I think it would be useful to take a moment now to level set on what they are. So starting on the left, we have EC2, and EC2 stands for Elastic Cloud Computing, and these are your virtual instances. So when you think of AWS EC2, think of virtualized servers or computing power. Okay, when you look at S3, this is your storage, and there's multiple mechanisms of storage in Amazon. So keep in mind that for the purposes of this webinar, we are simplifying so we don't try to boil the ocean all in 1 hour. The infrastructure is very feature rich and full at AWS. So we're trying to minimize the scope of what is possible, just to give you a practical and pragmatic example of what you can do in DR. CW is CloudWatch monitoring. This is your monitoring and notification of your systems. This tells you if your disks are getting too full, or if your memory or on a particular EC2 instance is running at a higher than whatever you define as a threshold, something of that nature. ELB stands for Elastic Load Balancers. These marry up to your traditional load balancers, which allow you to horizontally scale a solution by adding other instances into the cluster so that you can handle more user load, more transactions. Elastic Block Storage, another form of storage from an AWS perspective, although it differs from S3 in that S3 maybe you could think of sort of as detached storage, whereas Elastic Block Storage you might think of as additional drives that are mounted onto a specific instance. RDS, Relational Database Services, think of this as Microsoft SQL Server, MySQL, Oracle in a box that right off the shelf from AWS, comes with built-in backup and redundancy, and allows you to very quickly provision database instances for your applications to persist information on. R53 stands for Route 53, and this is the virtualized DNS service that's offered by AWS. And lastly, Elastic IP addresses, and this is the ability to map a fixed IP to an EC2 instance. Okay, so with I'm going to leave that up for the duration, and I'll just turn it down a little bit so you can focus on the next piece, and we'll get off to the races here. When you look at possibilities for harnessing AWS as a disaster recovery environment, one of the things that you want to consider, in addition to what we talked about in the beginning, is how much time does your organization consider an appropriate tolerance for being offline given a disaster event, and how much data loss, but certainly cost. And there's generally a sliding scale between some of the different DR models that are available in AWS. And that sliding scale basically starts with basic low-cost solutions, and as the price of the solution increases and the complexity of the solution increases, things like your data persistence and the amount of time you'll be offline, okay, decrease as well. So when you look at the different models, keep in mind that they're going to be gradually getting a little bit more expensive, but still, even in their most robust and verbose modes, still much less expensive than a rack metal infrastructure. Let's go ahead and define some of these models that I've been speaking about. The first we're going to call backup and restore. And backup and restore is going to be familiar to customers that have traditional tape backup solutions, where they take their data or their file systems, and every night they back them up to tape, and then they ship them off as per best practice to an offsite location for storage. Of course, implicit in that is, given a disaster event, you would need to restore from tape to a new environment, and if that is not on premise, then of course you physically would have to move those tapes to a different environment. Okay, we're going to take a high level 10,000 mile high view of some of these different modalities, and then we're going to come back and talk about them a little bit more in detail. So the second disaster recovery mode that we're going to talk about with AWS today, we're going to call the pilot light solution. And this is the concept of leaving only enough infrastructure running on AWS's DR environment so that your data synchronizes, and everything else will be shut down until you need it. So one thing that I want to pause and take note here of is, in AWS, this is computing as a utility. This is like your light switch at home. When you flip the light switch on, your meter spins faster, you spend more money. When you flip the light switch off, the meter slows down because you're using less electricity, and you're only paying for the electricity that you use. Similarly, in AWS, if your EC2 instances are turned off, then you're not going to be charged for that, because you're charged by computing hour. So with a pilot light solution, enough computing on in your DR environment so that you can replicate your data, but the ability to serve applications and accept transactions and user logins and things of that nature is turned off unless there's a DR event to reduce your cost. The third model we're going to call a warm standby. And warm standby is similar to a pilot light solution from the standpoint that your data is replicating real time. However, unlike the pilot solution, you're going to be adding infrastructure, EC2 instances, for example, that are on all of the time. And because they're on all of the time, you're incurring some additional cost, but your speed to being able to serve requests both by users and transactions and applications significantly increases, because these instances are already up and running, and it's a matter of rerouting requests to your DR environment only, not spinning up your DR environment. The last model that we're going to talk about today is we're going to call multi-site or active-active. And in multi-site, or active, it is, I'm just going to, here we go. Multi-site active is essentially very similar to warm standby in that your infrastructure is up and running, except that you're routing traffic in a multi-site solution to your DR solution in addition to your current production solution. So you're effectively allowing your DR environment to carry some of the yoke of the strain that's put on production systems on a regular basis. And there are some specific reasons in addition to time of recovery why that is attractive to some organizations. Okay. Let me pause for a moment and check in with Russ and Susan. Are we receiving any comments on the webinar thread with respect to speed and depth?
Well, I'm sure you won't be surprised that the feedback of question that we get here is we got a lot of technology people on this call, who are probably right with you and saying, please hurry up, bring me more. The business folks are starting to go, well, what, can you give me some idea on cost savings here? And I know that's an unfair question. I'm sure most people on the call realize that as well. Until we know what your actual DR environment is and what we're going to build, it's impossible to know that. But we've done enough customers here. So the folks going with the more complex, more expensive, 3 warm standby or 4 multi-site, do we see 10% savings, 20% savings over traditional rack metal?
Sure. Yeah, and Russ, I think your point is a good one, that it would be hard to do a cost comparator directly because every data center has different costs. But let me give, before we go any deeper, let me give some semblance of cost here. And I'm going to need to architect very quickly here a fictitious environment. And that fictitious environment, let's say, is going to be a MySQL database and let's say a Tomcat application server that's serving web pages. And let's say, for example, that in addition to that, we're going to have 150 gigabytes of storage in S3. Okay, so and keep in mind S3 up here is your storage buckets for persisting, one of the means of persisting data. So if we were to look at this, and this type of a solution is very typical for MySQL, Java, Tomcat, for you to be able to host a web application that persists data. But these parts are interchangeable. This is only a fictitious example. If you were to look at a pilot light solution, where you're probably at most going to look at 15% utilization, versus over here we're going to look at something more like 100% utilization. Remember, pilot light solutions we're only leaving enough of the solution on to replicate data. Your estimated monthly cost for this solution right here would be about $65. Okay, and I've taken some liberties to estimate general. This is a medium-size instance with some rough estimation of the amount of data transit between the solution and its users. But generally speaking, let's say about $65. 100% of the time, for 100% utilization, you'd be looking in the neighborhood of about $275 per month. Okay. Now, these are, again, some rough numbers taking into account assumptions. The architecture here, the same MySQL Tomcat instance, 150 gigabytes on S3, 100% utilization, $275 a month, $65 a month for 15% utilization. So if you're looking at a rack metal data center and you're looking at purchasing a 1 or a 3-year contract for rack metal infrastructure, or if you're in a colo environment where you're purchasing the hardware as a capital expense and then getting ping pipe and power from a colo scenario, you're looking at numbers not only that are significantly higher than this, but you're looking at a capital investment upfront. Whereas here, you're able to invest only in the solution that is appropriate for your business need today, and you can very quickly provision tomorrow to match an increase in business or technology needs. Russ, do you want to decorate that, or do you want to help drive the question any more specifically than that, or should we move on?
No, thanks, Eric. I think that's great. That's enough to keep the business people that are, I think we see signed up for this, entertained, and hopefully that sort of knowledge that it's not just an incremental savings; it's somewhat groundbreaking savings is enough to keep them entertained. And now we can go back to the technology for the technology folks.
Okay, great. So let's, since we've already established one example, let's use that example throughout. Where let's say that we have a New York City data center, where an office has a rack metal server in a server closet in their office, and here you have AWS. And let's say that there is one database, one server in on-prem in office. Basically, what the backup and restore model is, typically the New York City office probably has an IT personnel responsible for backing up to tape and then keeping track of both full backups and incremental backups, and then shipping those tapes off-site for as a best practice in the event that something happens to the building, the sprinklers go off and destroy some of the infrastructure. In the backup and restore model in AWS, your database backups and file system backups both are going to go to S3, okay, up in the cloud, and now they're available in the cloud. And the first point that I want to make is, unlike tape, when you look to restoring to a different physical location, you have to once again get that tape to that location, in addition to purchase upfront the hardware required to run the infrastructure in that new location. In S3, since it's in the cloud, that data is already available globally. Okay, so you can pull that information down globally, or even better, from S3, you can leave it in AWS and spin up your EC2 instance here and your RDS instance here. RDS, again, being your relational database server. You can take your backups and restore them here, and you can be off to the races in AWS for your DR environment, and that's your backup and restore. Now, even better than that, to reduce the amount of time required to get back online, the RDS instance and EC2 instance can be provisioned in advance. If you're like most organizations, your application code is, while it certainly changes, it's probably not changing every night like your data is. So let's say you're an organization where every quarter you're releasing a new version of a web application that your customers or employees use. Well, then, every quarter you can update and refresh the EC2 instance with that new version. Now you can be on version 2 of that application instance. But other than that, the EC2 instance can be left off. And by the EC2 instance being left off, you're no longer paying for it, because it's like that light switch. This is computing as a utility where you're only paying for what you use. Okay, so that's a little bit more in depth on backup and restore. Keep in mind our sliding scale here, and this is your lowest cost solution and your highest time solution in order to get to promote your DR environment over to production. The next we're going to talk about is the pilot light solution. We're going to keep this example rolling. Okay, so you have your New York City and AWS, and your line down the middle here, just as we were talking about before. You have your MySQL database and you have your application server. Okay, here the differences are that your RDS instance on AWS, you're going to leave that running all the time now, and you're going to replicate your data to RDS. So in doing so, your data does, in the event of a DR outage, you are not going to have to take from backup, like in backup and restore, where you have to take that backup and push it to RDS. You're not going to have to do that in a pilot light scenario because replication's happening real time. So that's an increase in your recovery time that you're going to be able to get to your serve production requests faster, because that's one less step that you'll have to accomplish. But more importantly, in my opinion, is the data loss, because the implication with a backup and restore is that that backup happens, maybe every night at 1 a.m. Okay, so anything after between 1 a.m. on Monday and 1 a.m. on Tuesday, if that's when the disaster event occurs, you're going to lose anything in between those two incremental backups. Whereas with replication, once you get to a point where a disaster event occurs and knocks New York City database offline, RDS is okay. RDS has all the data up until the point where the instance went offline, and now you can pick up where you left off by turning on your other EC2 instances. And here we kind of simplified in this example, one EC2 instance. It can be one, but it could be three, right? You could take these three and put a load balancer in front of it and have all requests coming into the load balancer, and then the load balancer will disperse those requests across multiple EC2 instances. And this is, even though we're giving you a very simple example, I don't want you to feel like this doesn't scale to the largest of use cases, because it does. And in the case of the pilot light solution, these instances would be turned off under normal business operations. So again, computing is a utility, you're not paying for them, and only RDS is left on for data synchronization. Okay? We're going to make a little bit of room because I was never good at coloring inside the lines, said my kindergarten teacher, Mrs. Thayer. And now we're going to come over to warm standby, and we're going to keep the example going here, right? We've got New York City, we've got AWS, and we've got, yeah.
Hey, sorry for interjecting. We're getting some more customers coming in. Some of them, this one's more technical. Wondering, can customers use a gateway or API to move data to S3 from on-premise, and which is easier?
Yeah, well, there are multiple ways to access data out of S3, and there's a multitude of client tools that are widely available to access data from S3, in addition to APIs. So more technical organizations that are looking to put some automated workflows around backing up to S3 and retrieving data from S3, you can certainly write programs and scripts around that. Less technical organizations that are looking to have some sort of like a graphical user interface to be able to move things to S3 and retrieve things from S3, that's certainly possible as well.
Thanks, Eric. And trust me, everyone that's listening in, you're happy to have Eric drawing and not me. Thanks, Eric.
Thanks. Okay, so warm standby is a little bit different yet, okay, because this has your RDS instance replication, which we talked about before. Remember, RDS replication means that in the event that a disaster occurs and knocks your database offline, RDS is up to date. But in this example, it's a little bit different because your EC2 instances are online. Now, in this case, however, traffic is only flowing, production traffic is only flowing to your New York City data center, okay? And it is not flowing to AWS. So all production requests, either from users, web services, APIs, or and any request coming into your applications or your data, is going to go to your primary production environment unless there is a DR event. And in the case of a DR event, you will reroute your traffic to AWS, and you will remove any routing of traffic to your primary production environment until it is back online and verified. And once it's back online and verified, you will basically toggle and reverse that action and bring traffic back to production. Okay, so in this scenario, because these EC2 instances right here are left online all the time, I think you're seeing that the amount of time required to accomplish a warm standby return to service gets much shorter. Going back to tape backup and restore, you're having to turn on this infrastructure. You're having to bring down data from S3 into your infrastructure and then get it ready to go. So that takes a little bit more time, but is a much lower cost solution. And that's why in the beginning we kind of defined this sliding scale here, as the features increase and the amount of time required to get back online decreases, the cost goes up somewhat. But if you remember, we talked about a factor of pricing here of 15% utilization and 100% utilization. Remember, back here we're still looking at for a single EC2 instance of medium size and a single RDS instance of medium size and about 150 gigabytes of data in the database in S3, you're looking at about $64, $65 per month. And out here, you're looking at something in the range of $275. I want to be clear, and I think this is assumed, but we're obviously not drawing out quotes here in the webinar with our virtual whiteboard. We're trying to give you a rough order of magnitude of pricing. Every solution has its own intricacies, and one of the things that LTech does very well is we can sit with our customers and get to understand what exactly your business requirements are, what are your architectural requirements, and more so, how does your company wish to innovate? Because what we're describing right here, these are innovation roadblocks. If your IT department is spending their time figuring out how to get their tape back up, verified, and stored off-site, that is time that they are not spending innovating and bringing new solutions to your users, to your customers, and allow you to maintain a competitive element with other people in your industry space. So back to finishing off warm standby here, because these EC2 instances are online and sitting basically in that warm standby mode, you've left the car warmed up and running. It's just a matter of getting into that vehicle and driving off at that point. So the last modality that we're going to talk about is the multi-site or active-active environment. And I think by active-active, you can probably surmise where we're going here. So you've got New York City, and you've got AWS, and you've got your database, and you've got your application server. So much like your production system, your primary production system, you're gonna have data replicating to RDS, but now you're also going to have data replicating back to production. Why? Because traffic is going to be allowed to flow simultaneously from different user requests into each of these two solutions. What this will do is this allows the investment that you're making in your DR environment to carry some of the weight of the request and transaction load that is being put onto production. And because everything is replicated in real time, if you have a disaster event that brings New York City database offline, you can trim the connection to your New York City primary data center, and you can allow only traffic to AWS, and you're going to stand on one leg until production comes back online. When production comes back online, then you will resynchronize your data and be back in a fully production two-legged environment. So one of the things that's interesting about this solution that I want to bring forward is when going back to the regional map here, if you are an organization that is multi-site, if you have an office in New York City, but you also have an office, let's say in South America, if you put your DR environment on AWS in South America and you use active, okay, and this is New York is your primary production, um, because your DR environment is handling production load, you would have less latency than having your Brazilian employees continually hitting New York for for data and for requests. Here, you can have Brazil contact the Brazil DR environment, which is running an active. New York will contact New York, and in the event that New York goes down, your primary data center goes down, you can have New York access your DR environment there. And you can also do a hybrid solution where perhaps you have another DR environment that is running as a pilot light solution on the West Coast. So there's more than one. I think what I'd like you to take away from that little sidebar is that there's more than one way to approach this. And just because we've defined some of these modalities as individually doesn't mean that you can't combine them for your organization, depending on its size and needs and your where your user base is. Maybe it's appropriate to have multi-site active to support some remote users in another area of the globe. But also, as we mentioned, have a pilot solution that leaves the pilot light on the West Coast, and that gets turned on in addition to your South American DR environment in the event of a disaster event. Okay, so let me pause. I can't see if your heads are nodding or if your eyes are rolling back in your head. Hopefully it is not the latter. Let's pause for a moment and let's get some questions from from the folks that are attending the webinar.
Sure. Hey, we do have a couple other questions, Eric. I don't know where you are time-wise. If you have more to cover, these can wait and be answered offline. But a couple of them are interesting. One is, in addition to backing up my data, can I archive data for longer-term storage? So I have to use an Iron Mountain type of solution for that type of functionality?
Sure. Okay, it's a great question. I'm going to go ahead and, well, you know what I'm going to do? I'm going to turn this off and turn this on so I can do a little bit more drawing here. The question is, can you use? Do you have to use an Iron Mountain solution for archiving? Is that correct, Russ?
Yeah, exactly.
Okay. So while you're certainly welcome if you're an Iron Mountain customer to use Iron Mountain to for your backups or archives, by no means do you have to. So AWS offers an archive solution called Glacier. And to give you a little bit of a comparison between S3, right, that's your storage, simple storage service, and Glacier, let me give you a couple of key differences here. Glacier runs about, and this is roughly, about 8.5 cents per gigabyte per month for storage. Glacier runs about 1 cent per gigabyte per month for storage. Okay, the primary difference other than price is the speed. So S3, when you put data into S3 for backups or for storage, or even to serve content to EC2 instances, it is immediate. Okay, very fast. Here you're looking at a delay, and it's really intended not to be online storage, but nearline or offline storage for archiving. And you might expect something in the neighborhood of a 2-hour delay to after requesting a data retrieval from Glacier. But if for the person who asked that, if you're coming from Iron Mountain, then you know that that if you're requesting a box to be shipped back from you from Iron Mountain, 2 hours is looking pretty good. Okay, so I hope I answered that question. Any others?
Sorry, I was
Russ?
on mute. Sorry about that. Yeah, we have several more. So, by the way, those of you who don't get your questions answered, we'll have AWS at LTech.com where you can submit your questions, and we'll get to those after the webinar as well. A couple more I wanted to ask. One is our organization requires periodic turn-up of DR for 48 hours 2 times a year. Plus, we use DR during large-scale upgrades to our production environment. Can we still use backup, restore, or pilot mode model given those requirements?
Yeah. Oh, okay. So sure. So the question is basically saying that at times this organization wants to use their DR environments as a forced push to DR, so that if I'm understanding the question correctly, a forced push to DR so that DR can handle their production load, and that the maintenance can be performed on their production environments. And whether or not that is a case that can be supported with either the backup and restore model or pilot light model. The answer is yes. From a backup and restore model perspective, what you would do is you would plan for this changeover event to happen. You call it like a maintenance window, and you would turn up your DR environment, configure it to receive production requests, and then at that point you can take your production system offline and be able to perform any said maintenance on that. Then on the change back over to production, you would simply need to take a backup of any data that was accomplished in the DR environment. So these are new transactions, new files, new changes to data, and synchronize them back via backup and restore to your primary production environment prior to bringing it back online. And that would be similar for, it really is an exact mirror of a tape backup solution. The only difference being that you're not dealing with rotating out tapes, you're not dealing with the expense of tapes, you're not dealing with the time that it takes to read and write from tape, and not dealing with the time, effort, and maintenance in managing those tapes, tape storage offline. So interestingly enough, we have one of our LTechers used to be an Iron Mountain employee. Russ is I believe he had some metrics about tape backup when we were talking about DR and AWS. Do you recall?
Well, yeah, you had some interesting metrics, not just about pricing, which was somewhat earth-shattering in the differences, but the real telling piece for me was that pieces that were stored more than 5 years had something like a 30 or 40% failure rate. So there was this scariness of what if you need it and it doesn't work.
Right. Right.
We actually have another interesting question, Eric, and this one's a little bit of an old school curveball. And my guess is it's going to need additional questions from us for us to answer it. But the question is, are any of these services available for mainframe applications?
That's an interesting question. Well, there is not a mainframe
That could be a
instance
whole
type.
nother webinar. So
It could be another webinar indeed. But let's take a quick shot at it. Let's see here, and see if I can get back into my drawing mode here. Well, let's try to field the question. So there is no IBM mainframe equivalent in AWS directly. So if you're coming from running software applications that connect to like Kix for transactional processing, or DB2 as a persistence layer on a mainframe, then something like that, there's not a direct one-for-one. Fortunately, I used to do quite a bit of software development and infrastructure consulting for some large international banks, and many of them were running a hybrid of Unix and Linux servers alongside mainframe infrastructure. However, if you're in a mainframe environment and your data can be synchronized via some other mechanism, such as software synchronization into the cloud, it would be possible. You wouldn't be able to have a one-to-one like a DB2 to DB2, but you could have like a DB2 to Oracle or a DB2 to another database flavor that wouldn't be synchronized natively, but could be synchronized via a software mechanism. And that would allow for, at a high level, that would allow for this type of replication and use of DR. So for whoever asked that question, forgive me if I'm staying 10,000 miles high on the response, but generally speaking, there would be ways to service those types of requests, and you should certainly reach out to us after the webinar so we can discuss it in more detail offline.
Great, thanks, Eric. Just to be respectful of time, Susan, I see we're at 1:54, so we got about 6 minutes left here before we have to let these people get back to their day. Anything else we needed to hit before we sign off here? Or take any more questions?
Yeah, Russ, I'm just going to show my screen again. Want to just tell people about some of the Amazon Web Services programs we have. So just a moment while I show you my screen. And Russ, if you just wanted to tell people about a few of our services here, that would be great.
Sure, and these are easy ways to get started. Those of you that want to know more, you can look at our website. And the first one is our cloud assessment package. There's also a disaster recovery quick start package, and those links go directly to our website where you can look at the packages we offer there. As we mentioned earlier, that AWS at LTech.com, a lot of you might not fit into those packages and want to have a more detailed discussion about what we could do specifically for your company. So please reach out to AWS at LTech.com and we'll get right back with you. We've got 1:55 here. Eric, we have folks. We have 4 minutes left. We're having some other questions come in. If you'd like to handle those for the last few minutes.
Sure.
One question is, how many users does LTech currently support on AWS? I can actually take a shot at I think that what might be interesting to customers is that we have some very small scale and large scale customers. One of our customers started with a disaster recovery environment and then ended up putting their entire production environment into AWS, and it now supports over 500,000 users. That's a pretty large one. Anything else you would add to that, Eric?
No, I think the it's an interesting question, and if the question is stemmed from is my business too small or too large for AWS, I'd like to just take a moment and talk about the elasticity properties of AWS and why it's appropriate for a small business environment all the way up through large transactional enterprise class applications and solutions. Not only is the amount of storage certainly extensible to meet the demands and requirements of large many hundreds of thousands of user types of applications, but in addition to that, there's really a sliding scale of the type of instances or virtual computing instances that are available and can be appropriately matched to your solution. But the other great thing about it, I mean, obviously, the more simply stated, the more CPU depth and memory depth that an instance requires, the more per hour you're going to be asked to pay for that. But for an organization that is, let's take like the classic startup. The classic startup doesn't need to plan for that today from the standpoint of going out and taking, you know, their precious startup funds. And I think any IT budget in today's day and age is precious and needs to be used, you know, wisely. And invest that under, to build in enough headroom to allow their solution to scale. And when they do that, I think the average utilization of these types of data center assets is like less than 30% utilization. Another way to say that is that 70% of that physical infrastructure that's provisioned to have enough headroom goes unutilized. And that's, that's, well, sort of a travesty. It's a travesty from the perspective of not only cost, but in that 70% of that computing power can be used to allow a company to innovate. And that is really what LTech enjoys when we work with our customers, is not only the look on their face when we can demonstrate to them the cost savings that we can that we can show them by using some of the tools and modalities that AWS offers, but now the time as well and the additional budget that's recovered as well, that allows organizations from startup all the way through to enterprise class to innovate and to focus to get back to the business that they got into in the first place, which was probably not managing DLT backup rotation schedules.
Hey, Eric, I don't think that 70% unutilized is bad at all if you happen to be the people making money selling rack metal.
Nice work if you can get it.
Out there might want to think about it. But, so we're at 2 o'clock, and we certainly want to be respectful. I see some people needing to leave already. We had another question that just came in about the sliding scale per gigabyte for the pilot solution, and I'm sorry I didn't get to that. We'll answer that offline. But thanks, everyone. Please do look at our cloud assessment package and our disaster recovery quick start, or be in touch with us at AWS at LTech.com. Thanks very much.
Thanks, everyone.